So guys, the question that we are going to solve today is this LinkedList cycle, and this is one of the most important questions from LinkedList, and this question has been asked in so many companies like Amazon, Paytm, Accolade, Samsung, DShaw, Microsoft, Oracle, and the list goes on. And today we will be learning two approaches for this question, but before that let's see what the question is saying. So we are given a head of the list and our task is to determine whether the list has a cycle in it or not. Cycle means if there is some node in the list that can be reached again by continuously following the next pointer, right? So in this case you can clearly see we can reach out to this node again by following the next pointer of this particular node. Okay, so this list has a cycle, so our task is to return whether the list has a cycle in it or not. Okay, so for this question let's see the first approach. So the first approach is going to be the extreme brute force approach, where we will be using a set to keep track of the visited nodes. So what we will be doing, we will be traversing the list, and while traversing we will store every node to the set, and if at any point we find a node that is already there in the set, that means that list has a cycle in it. Okay, so the same thing we have done here in the code. We have a set here, we started traversing the list and we are adding all the nodes to the set, and if at any point we find a node that is already in the set, that means the list has a cycle in it, so we will simply return true. And once the loop is completed, that means there is no cycle in the list, so we will simply return false. Okay, now let's see the second approach. The second approach is going to be the most optimized approach. Here we will be using two pointers, fast and slow pointer. Slow will move one step at a time, fast will move two steps at a time. Okay, so you can think of it like a circular ring, and on this circular ring there are two runners, fast and slow. They both start from the same point. So fast will complete one circle, then slow will only be completing half of the circle, right? And when fast will complete two circle, then slow will be completing one complete circle. So they both will meet at a same point. So the same thing, the same concept we are going to apply in the list. If my list has a cycle in it, that means both the fast and slow pointer will definitely going to meet at a point. And if they are not meeting, that means the list does not have the cycle. So the same thing we have done here. We have taken two pointers, fast and slow. Slow is moving one step at a time, fast is moving two steps at a time. And if they both are meeting at a point, that means the list has a cycle in it, so we will simply return true. And if they both are not meeting at any point, that means the list does not have the cycle in it, so we will simply return false. So I hope you got the logic now, and that's it for today. Share this reel with your friends who are learning DSA, and I will see you in the next video with another DSA concept.